All right, so these next two videos are just going to dig into transformations of sine and cosine graphs, what they look like, how we do them. And then if you go back to the one attachment that I have that has the different links and stuff to it, you can kind of see like how these are used and where they're used and how they come up just in nature, which is really kind of cool. But the transformations we're going to do on this video are all vertical transformations. So things that are going to change the y values in our tables and on our graphs. The nice thing with all of the transformations that we're going to do is if you've been successful with doing them all throughout the year, it is the exact same thing as the left, right, up, down, stretch, compress, reflect things that we've done throughout the whole year. So the algebra of it and the way it looks in the equation, exactly the same, which is good because we've had a chance to do that, through multiple formats throughout the year. So I have sine up here on the left with its table, with its graph. The first example we're going to do is -1 times sine of x. So here's my original graph. If I multiply something by -1, okay, it should look really familiar. When we multiply by a negative, what's going to happen to all of our answers is that the signs are going to switch, okay, which is basically just a reflection. Okay, and if I had room to type it somewhere on here, I would type that this -1 right up here is going to reflect the graph across the x-axis. It's going to be a vertical reflection. Okay, because ultimately what's that going to do to my table? Well, if I plug in 0, I'm still going to get 0. Like I can't reflect a 0, so this is still 0. When I plug in pi over 2, this is going to be 1 still, but then when I multiply it by -1, I'm going to get -1. Okay, when I plug in pi, I'm still going to get 0. 0 times -1, still 0. If I plug in 3 pi over 2, normally I get -1, but now if I take -1 times -1, I get 1. And then when I plug in 2 pi, I should still get 0. And I don't know why the clicker mark is up there, but that's a 0, not a D or a half note or anything. Okay. So what did it do? Well, it reflected across the x. It changed the signs on all of our answers, on all of our y values. So that's the thing you should notice. You don't need to do it like one point at a time. You see a negative in front of the problem. You see it multiplied by a negative. It's just going to switch all the signs. Okay, that's the key. Okay, and so then I graph it, 0, 0, pi over 2, -1, pi 0, 3 pi over 2, 1, and 2 pi 0. And then again, I can keep the pattern going because it just goes -1, 0, 1. And if I go backwards, 1, 0, -1, 0. Now it's heading up. And it's every 2 boxes because it's every half a pi still. We haven't sped up or slowed anything down yet. So it just keeps kind of rolling along. Okay, and so I'll do my best to kind of sketch this here. Rolling, rolling, rolling. Oh, missed that one. Okay, and the same rules apply as all year, even though I have no idea how I'm going to make this one happen. If you miss a point by a little bit, just take and make the point bigger. I can't justify making a point that much larger, so give me a second here to try to put that back together a little bit better. So I hit that point right there. There we go. Okay, so it looks the same as the original one, except for flipped. This positive one is now down in the negatives. This negative one is now up in the positives on this new graph. Okay, so those are reflections. Multiply by a number in the front, should flip it. Okay, so for example 2, it is a cosine function, so I switched the background one over here on the left, or I switched the basic one that we're working off of to cosine for you, and did my little drawing with a little bit of blip in there, but oh well. So again, 3 times cosine of x. The last one had a -1 in the front. If you multiply something by a negative, that should flip all the signs. Multiplying something by 3 does the same thing that multiplying any other function by a number will do. It will stretch it out. It will make it taller. This should be 3 times taller when it's all said and done. Okay, and that's a change of amplitude. Okay, so if you're making any little side notes on here, multiplying by a number besides 1 will change the amplitude or change the height of your waves. Okay, which again should make sense when we go through and fill out this table. Because now, when you plug in 0, normally you get 1, because cosine of 0 is 1. We have that over here. Well, and if you take 1 times 3, you're going to get 3. When I do pi over 2, cosine of pi over 2 was 0. 0 times 3 is still 0. And as I go through, I'm going to notice that I'm just taking 3 times the previous value. So that's why I have this old table here. So 3 times negative 1 gives me negative 3. 3 times 0 for the next one gives me 0. And 3 times 1 for the last one gives me 3. And so multiplying by 3 will make this wave, this graph, 3 times taller, okay, which we can now sketch. So the first point, 0, 3, is up here. Pi over 2, 0 is right there. Pi negative 3, so pi negative 3 is down there. 3 pi over 2, 0. And 2 pi 3. Okay, so the same V-type pattern to start out the graph, but now stretched out and made 3 times taller. To get the rest of the graph, again, you could either make a table or just look at this one and stretch it out. So this one here at 0 will stay at 0. This one that was at negative 1 will drop down to negative 3. This one's at 0, and this last one that was at 1 will now be 3 times taller. Okay, so it's that same cosine wave, and again, it'll be a little tricky to do here. Boom. But with a pen or a pencil and not a wireless mouse, I imagine you can probably draw a little bit better than I can. But the idea is to try to make it curved. So don't make it like a pure zigzag. Okay, it is a curve and not lines. Okay, I missed this one a little bit. Let's just make that point a little bit bigger. There we go. Okay, so that is cosine made 3 times taller. I increased the amplitude. The amplitude is now 3. Okay, and for example 3, well, our first two, we did a reflection and we did a stretch or compression. Okay, example 3 is the last vertical change we can make, which is just simply moving something up or down. Okay, so notice here with cosine of x plus 2. Okay, and the big difference here, a big thing to pay attention to, this is not grouped together. So this, as written right now, is very different than if I wrote it like that. Okay, 2 totally different ideas. When it's in parentheses with the x, we've learned all year that that is a left and right move, and that has an opposite sign. But when there's no parentheses, like this original example was, that number is just being added to the end, and that's completely normal. You see cosine of x plus 2, literally all you're doing is you're taking this graph, you're taking all the points in this table, you're moving the y values all up 2. Okay, so if you're like writing yourself little notes on there, and suppose, hey, I can do that. This is a move up 2. Okay, I wish I'd figured that out a couple minutes ago. Okay, so plus 2 on the end, moving your graph up 2 places. Okay, and so again, it's really easy to do the table of it, and if you want, you can also do the graph first and then make the table. You can do the table, make the graph. The idea is that you want all 3 of these things, actually all 4 of these things, to all be kind of in sync. So you've got the equation, you have the transformation, you have the table, you have the graph. They should all be speaking the same language and going in the same directions. And when you can start to do that, when you can start to tie them all together, that's when it's really cool, because that means that you've got the hang of it and you can just go without hesitation. So if I take this original cosine graph and move everything up 2 places, okay, where it was 0, 1, if I move it up 2 places, 0, 1 moves up to 0, 3. Okay, pi over 2, 0. If I move it up 2 places, is now at pi over 2, 2. Pi negative 1. If I move it up 2 places, is now at pi positive 1. 3 pi over 2, 0. Moved up 2 places would be up to 2. And 2 pi 1, this point right here, If I move it up 2 places, will now be at 3. So notice the difference between the original one and the new one. I literally just added 2 to all the y values. That just moves everything up 2 spots. Okay, and so then I just sketch. So we got 0, 3, pi over 2, 2, pi 1, 3 pi over 2, 2, 2 pi 3. So you get that same V shape, just shift it up 2 places. Carry that pattern backwards, so it's at the peak, because again, like right here is the middle of the graph now. So before the middle of the graph was at 0. Oops, trying to do a straight line there. Okay, here, the middle of the graph is now 2 places higher, so the middle of the graph's at 2. So just bouncing back and forth between 3 and 1 now. So bouncing back between 3 and 1. It's going to go there, down to 1, back up to the middle, back up to 3. Okay, and then do your best to connect it. Boom. Not perfectly drawn, but again, not too bad. This guy shifted up 2 places. So +2 up 2, -2 down 2, like normal. So those are the 3 vertical shifts, or vertical, I shouldn't say shifts, vertical changes or transformations that we can make.